So what I will do is I will like add two folder, let's say game, and so in game we'll have all the game related objects, and then let's say player, where I will add a player like human player and AI trainer, AI player, those means whoever can play this game, so those logic will come there. So let's go to game, and we'll add all the game objects. So if you see in the classical Dino game, what objects will have? We'll have a base, and on which the dino will run. Then we'll have the actual dino, and we'll have the cactus, the obstacle, where we can have like single cactus, multi cactus, like that, and then we'll have the bird that will come flying, and we'll also use clouds just to give a background effect. So let's go and start with base, and let's add that base class and the logic related to the base. So what we'll do in game, we'll add one file, let's say base.js. so let's export as class, let's give a name as base. Okay, let's define a constructor for this base class, and let's define the x value. So we'll have 2x, so that basically we want the base to come repeated one after the other, so we'll draw it 2 times. So the first one will start from x0, means the extreme left, and the second one will start where the first ends. So we are giving the image width as the starting position for the second one. Like if you see here, but this extreme left will be the where x will be 0, since our top is the origin and right side is positive x and down is positive y. So the extreme left will be our x0, and let's say it comes till this point, then I want second image again to start from there and keep and enter there. So that's why I'm using 2x, x1 and x2 here. So let's add the our draw method here, and it will accept context as the parameter on which we can draw the images, and let's use context. So let's use context dot draw image, and first parameter should be actually image. So let's pass that util dot images dot base, and then we need to pass the like position where we want it to be drawn, so the x and y coordinates. So let's say that this dot x1, and for y let's give let's say we want the base to come at the bottom 10% of the canvas. So since it starts from the top y direction, so we'll use like total height into, let's say 0.9, that will cover like 90%, so it will leave on the top, and then it will draw our base on the bottom 10%. So let's keep that, let's say settings dot, and we'll use win height into, and let's give 0.9. So since our win height is, let's say 500, so it will like draw at 450 from the top. Okay, let's repeat this process, and this time let's do this dot x2, and the y will remain same, so that it will come side by side. So now we have the draw logic. Then next thing will be the move logic, means every time our screen refreshes, the base should move towards the left, so it will give the effect like our dino is moving forward towards the right. So what we'll check first is, if let's say the first image is already crossed, so we'll check this dot x1 plus the image width. If this is like less than 0, means we need to reset the position so that it comes after, let's say, the second image. So what we'll do is we'll reset the x. So let's say this dot x1 is equals to this dot x2 plus the image width, so that the x1 will again come like after the second image, so it will keep repeating like this. So same way we'll do for the second image also, means if the second image crosses the screen, we'll put it after the first image. So x2, if it like x2 and image width is less than 0, then we'll reset x2 to start after x1, so x1 plus image width. Okay. Once this is done, we'll move it towards left. So let's say this dot x1 equals to settings dot reduce the game speed. So currently let's say game speed is 4, means it will move 4 unit leftward, and even this means first image will move leftward by 4 unit, and the second image should also move towards left, so it will like together move and will not come any gap and all. Okay, so with this the move logic is also completed for base. We have only this functionality for base, like either we can draw it or we'll move it. Okay, so now let's add the cloud. Let's create a file cloud.js. Same way we'll export cloud class. So export class, and let's name it cloud. Okay, let's add a constructor here. And let's define the x for this. So the initial value will be like the cloud will be rendered at the extreme right, and then it will keep moving left with dynamic value. So basically at the starting we'll render it like at setting dot win width, so extreme right. And then let's add the draw method. Let's pass the context as parameter, and then similar way we'll add like ctx.draw image, and then let's pass util.images .cloud. So in cloud we'll have this cloud image, and then so here in cloud I have added this cloud image reference, so that can be referred here. Then for x coordinate, let's say this dot x, and y will use the constant y, so every time it will render at the same position. So let's say it is render here, then it keep moving towards the left, but y will not change. So we can refer this y coordinate from like setting, and x from this variable which can dynamically change. So let's say settings dot cloud y. So there like I have defined 200, so it will come like from top 200 unit, there it will come and it will keep moving towards the left. Okay, so pretty much done for draw. Let's add the move method. So in move basically we'll change the x coordinate and move it towards left, and once it like crosses the extreme left, then we'll add it again, so we'll reset the x value. So let's say if this dot x plus the like width of the image. Okay, if the width of image is less than, let's say 0, then what we'll do is we'll reset the x position, so it is again rendered at the right, and otherwise like we'll just reduce the value of x by game speed. So now this is base is done, cloud is done. Let's go ahead and draw like cactus and bird. Okay, so similar way we'll like go to the game folder and then add like cactus.js, and let's export again the class. Let's name it cactus, and let's add the constructor, and let's add like one variable called image, that so that when we are creating the cactus we'll add the image, since the cactus can have two images, either single cactus or multi cactus, means three cactus at three cactus image, so that we can accept like when we are creating the cactus object, that time like which image we want to use. Okay, then let's define the X position. So again it will start from the extreme right, so let's say settings dot win width. So from there it will start and come towards left. So let's import setting. So let's say X is settings dot win width, and let's define Y. So Y is like settings dot let's say win height into 0.9. So it is like where our base starts, and then we'll reduce the height of our cactus. So since we have to give from top where the image rendering will start, so we have to from the base, like where the base is, we have to reduce the height of cactus. So it will start from there and cover till base. So let's say minus settings dot cactus height. So actually we are not using image height here, because for cactus will define the height and width in our settings dot JS file, since it will help in collision detection, and also we are not going with image height. Then let's go with the draw method. It will be similar, like we'll accept ctx, then ctx dot draw image, and this time will not refer image from util, instead we'll use from its variable this dot image, and then x and y also we will refer from here. And the thing is, here we'll add the height and width explicitly, so that it will have like a fixed height and width, which will help us identify its location during collision detection. So we are giving like cactus width and cactus height from setting.js, and not leaving it on like image width and height. Now let's add the move method. So for cactus also, like every time the screen refreshes, its x coordinate will reduce by let's say the speed of game. And what we'll do is, every time the cactus like moves, will increase the speed of game as well, so that the game will keep getting faster. So what we'll do is, we'll add some factor to this. So let's say settings dot game speed factor. So we have defined it in settings there, so it will keep adding 0.01 value, so that the speed will keep increasing. Okay, next let's add a collide method. So it will accept a Dino object, and then we'll compare the x and y position of Dino with the x and y position of cactus, and check if it overlaps, and then it will return true or false. Means if it overlaps, it will return true, it will return false. So first we'll check if the x position of Dino is within the x range of our cactus. So we are checking like Dino x plus Dino width. So we'll create the Dino object, and there will have like x and y and width height of Dino defined there, so we can refer those from that object. And what we'll check is, if the right side of Dino is like greater than the left side of cactus, extreme left, that means it is like of right side of the our cactus. And then again we'll check if like left side of Dino is less than the right side of cactus, means it is within the x range of the cactus. So let's say x position is overlapping. Now we'll have to check the y position as well, because it might be possible like Dino is jumping, so it is within the x range but not in the y range, like it is above the cactus. So we'll have to check that part as well. So now let's add the y collision check, means if it is overlapping in y direction as well. So let's say dino.y plus dino.height, means the bottom part of our dino is greater than like the starting or the top part of the cactus, means this dot y. If this condition met, means there has been collision of dino with the cactus, and this method will return true, otherwise it will return false, means there is no collision. Okay, so now cactus is done. Let's go ahead and create bird class. So again we'll add one new file, let's say bird.js, and export it as a class, export class bird. Let's add a constructor. Here let's create a x position, so it will be like setting dot pin width. Again it will also start from the extreme right, and then let's say this dot y, and this will refer from setting. It is gonna be like fixed position, like at 365 the bird will be spawned, and it will keep moving towards the left on the same height, so that to protect Dino can duck, so that it is not hitting the bird. Then let's say bird image index, so we are defining it as 1 for now, so we have 2 images for bird. Let's say bird down flap and bird up flap. So what we'll do is whenever bird moves, we'll keep changing the image, so that it will give a flying animation kind of effect, so that we can control from this image index. Now let's add a draw method, so it will be like similar to other draw methods. Let's say ctx dot draw image, and this time what we'll do is we'll refer util dot images. Let's import util first. Import util from double dot slash util dot js. Okay, so we'll give util dot images dot bird, and then the bird is array, so there we can pass image index. So whatever image index is there, based on that it will draw, and will control this image index to be just 0 or 1, so that it will pick one of the image to draw. Now let's give the x and y coordinate. So let's say this dot x and this dot y. Here also let's give height and width from settings, so that it will be easy on collision detection. So let's say setting dot bird width and settings dot bird height. Okay. Now let's add the move method. So it is gonna be similar to the move method in Cactus. So let's say this dot x. Okay, so first what we'll do is every time it moves, we'll generate a random number between 0 and 1, so that it will pick that image, like either down flap or up flap image will be picked based on that. And same in the next draw, same will be rendered. Then let's say this dot x, and we'll keep reducing it by game speed, so it will keep come from right to left. Now let's add the collide method, similar to what we have in the Cactus. It will accept a Dino object and check its x and y overlapping. So the difference here is in the Cactus we have once Cactus hit the means once Dino comes in the Y range, we don't need to check the bottom range, like if it went like below the Cactus, since the Cactus and Dino both run on the same base. But for bird, since bird is flying in the air, our Dino can be above the bird or below the bird. So we have to check both the condition, means it is not just overlapping in one side of Y but both side of Y. So first we can check the X overlap, then let's now check the Y overlap. So Dino.y plus Dino.height is, let's say, greater than this dot Y, and let's say Dino.y, and we'll check if Dino's Y is less than let's say the bird starting plus the height of bird. If this condition met, again means collision has happened and it will return true, otherwise it will return false. Okay, finally let's add the Dino class. So let's add Dino.js and export it as a class similar to other files. Let's export class Dino. Let's add the constructor here. Let's say this dot image in image index, and we'll initialize it with 0. Again, now here we have 4 images for Dino, 2 for running and 2 for ducking. So this image index basically pick like based on if our Dino is ducking or not ducking. We'll pick the duck image, and then this image index will decide if it's like ducking or running on the left or on the right. So it will swap the image. Then let's say the max Y the Dino can go. So what will happen, the X and Y the Y will keep changing for the Dino when it jumps or duck, but the X will be the same. So since Y is gonna be variable and we want the max Y to be till the base, so we can define the max Y so that we can reset it if it tries to go like below base. So what we can do is let's say where our base is, so it's like setting width into 0.9 that we have defined our base to be, and then like how much height the Dino has. So based on that we can calculate the maximum Y. So it's gonna be like reducing Dino height from the base location, and the initial value of Y also let's keep the same value, and then let's say Dino X, and let's refer it from settings. So let's say Dino X, and we have defined it to be like somewhere here it should come. So we have defined it to be 100. So it will be on the left side, say the velocity that Dino will have. So initially let's say its velocity will be 0 and the tick will be 0. So this tick will basically refer to the time stamp, how much time the Dino is in the air, and it will help in calculating the displacement. Then let's create one jumping variable which will help us track if the Dino is jumping or it is on the base. Since suppose we pressed the space bar and it is jumping and in the air, and we press the space bar again, so we don't want it to jump again from the air. So we have given like we use this flag there. Then let's say image, and we'll use like images from Dino. Let's say by default we'll use the normal image, not the ducking one, and we'll refer this image index. So it will basically use the first image from the images that we have loaded during loader set. So by default it will use that one. Then let's define the width and height. So by default it will be like Dino width and Dino height, and we have another set of height width like when it is actually ducking. so there the height will reduce so that it will not like collide with the bird. So if you see here, we have 50 and 60 as the normal height width, and when ducking it will be 45 and 40. Let's add the draw method similar to like other. So draw image, and we'll refer to the image that it has, like this dot image. Let's keep the x and y position, so this dot x and this dot y, and let's refer to the height and width also, this dot width and this dot height. Okay. Let's add the jump method. So whenever, basically this jump method will be called from the controller, and let's say when we are calling the jump method, if it is already jumping then nothing should happen. So if it is not jumping, it's not this dot jumping, then we'll add the logic for jumping. So let's say this dot tick will be reset to 0 every time it starts jumping, so that the displacement and all will start calculating afresh. Velocity, like every time it jumps, will add some velocity, the initial force with which it has, like it jumped. So let's refer that from settings dot jump force. So we have given like -4, since our like downward is gonna be positive y, so upward will be negative y, so we have given a negative value there. So -4 means it will try to jump upward. Then let's say jumping is equals to true, so while it is in air this jumping will remain true, so then the jump will have no effect. And let's reset the image, so every time it jump, even if it is ducking, the image should be reset to the normal upright image. So we will refer to Dino image and the image index, it's either left or right one. Okay, so let's add the duck method now. So whenever this method will be called, the Dino will start ducking. So first of all we will check if it's not jumping, means if it's jumping, ducking should not have any effect. If it is on the base, that time only like the ducking will have the effect. So let's say it is not jumping, then this dot width will reset the height and width to ducking width and height. So let's put that one, this dot height is equals to settings dot Dino duck height, and then let's reset the image. So this dot so first of all when we are resetting the image, since the height width had changed, so the y, we have to lower the y should start below, otherwise it will keep like floating in the air above the base. So that we have to put here. So let's say we'll reset it, and instead of Dino height we'll minus the Dino duck height, so it will start from lower and go till base. Then this dot image, and now we'll refer the duck image. So images dot Dino duck, and then based on whatever index it is, it will be either like left side ducking or right side, means the left leg is forward or the right leg is forward. So let's do that. Now let's add the unduck method. So when this is called, we'll reset the ducking. So again let's check if it is not already in jumping mode. will reset the width and height again to the normal Dino width and height. It will be settings dot Dino width, and this dot height is equals to settings dot Dino height. And let's reset the Y also. Let's copy this from here and put it here, so it will reset the Y position. And then let's reset the image to normal Dino image. Finally, let's add the move method. So what the move will do is will calculate the displacement and all, and we'll see where its Y coordinates should be based on if it is jumping, ducking, or normal position. So what we'll do is we'll like change the image index. So we'll increment the image index by 1 and then modulus it with 2, so that it will keep going like 0 1, and then again when it become 2 it will reset to 0. So it will keep going like left leg forward, right leg forward, so it will give a effect like it is running. Then let's say this dot jumping. If it is jumping, then we'll calculate the displacement and change the Y coordinates. So basically we'll like every time it comes here and it is jumping, will increase the tick by 1. Means the time it has been in air will be increased. Then we'll calculate the displacement using one of the science formula. Let's say ut plus half at squared, where like u will be the velocity, t will be the time, and a is going to be acceleration. Here we'll have like the pull by the gravity. Now let's replace all these values here. So let's remove u and add the velocity here that we have. So this dot well into the time, that is nothing but the tick, and then 0.5 into the gravity that we have defined in settings. That will be the pull by the gravity, that will be the downward pull, so it's positive 0.4. and then let's multiply with tick 2 times, so it will be like time squared. Okay, so this will give us displacement value. Now based on this displacement, we'll check like what's gonna be the Y position, and if it's like going beyond the boundary, let's say below the base or above the window height, then we'll reset it. So first let's say if this dot Y plus displacement, if it's like let's say greater than the position of base, so if it's greater than max Y, so max Y is where means the position of base will be touched when it is at max Y. So if it is greater than max Y, we'll reset Y to max Y, so it will not go beyond that limit, so the it will be keep touching base. And then we'll make jumping false, means it has touched the base, so it's not jumping anymore. And then we'll reset the tick to 0 again. If like it's not meeting that condition, but it's going upward, and that time it touched the like height, like top boundary, so we'll check that condition as well. If this dot Y plus displacement, like displacement can be positive or negative, so if it goes like less than 0, means above the top, then we'll reset it to 0. Otherwise what we'll do is we'll normally reset it with like adding the displacement. So this dot Y plus equals to displacement, so it will move by how much the displacement is. And if you see initially since the velocity is more in negative, and tick is less means the ut, that is velocity into time, will be more, and the half at square part will be less. So the final result is going to be negative. So the dino will go upward, and as the time increases, the right side will become more and the left side will be less. So the final outcome will be positive, and the dino will start falling down. So it will give a nice moving effect, like it is going up, then going, the gravity is pulling it and it is coming down. So with this, all our game objects are added. Let's go and add the players. Okay, so inside player, let's first of all we'll add the human player logic, like we will be playing the game, that part, and we'll make the game playable. So inside player, we'll first add let's say human.js, and then let's export it as class similar to other files. So for export class, let's call it human player. Okay, then let's add one static variable which will decide like if it's in jumping mode or not. So in Dino, like we are checking if Dino is jumping or not. Here we'll actually keep track of if like we have pressed the key space bar to jump, or the arrow button to duck. So that part will be tracking here. So we define two variables, jumping and ducking. Then let's define two more flags. So adding bird, initialize it with false. So this will help us add the bird and cactus. So basically we'll keep tracking such a way that we do not add too many cactus or bird. Then now let's define one method, let's say async play. This will have all the play logic, and it will get the context, and it will here only will have draw logic also. So this context will be forwarded and it will be called from this main method. So whenever we click on this play button, it should invoke this method. So here what we'll do is we'll create object of our human player and then invoke the play method. So let's say human player, new human player, it's been imported. Okay, let's call the play method human player dot play, and we'll pass the context. Okay, let's do one more thing. Let's prevent the default behavior of event. So we'll add event.prevent default. Now let's add the game logic here. So first of all, we'll add the event listener for our key presses. So let's say document.add event listener, and it will be like key down event. So when the key is pressed, and let's add the callback method, and it will get the event that is triggered. And let's check for the event code. Before that, let's prevent the default behavior, and then let's check if event.code is like space key. So let's say space, then we'll say like human player dot jumping is true. Means the space bar is pressed, means our Dino will go into jumping mode. Okay, else if it's not a space bar pressed, but instead let's say arrow down key is pressed, so like it is a duck event, so we'll make our ducking true. Let's do the similar logic for key up event. So when it's key up, will reset the jumping and ducking to false. Like when the space bar is released, the jumping will become false. When the arrow down is released, it will become like ducking will become false. Now what we'll do is we'll reset the game speed. So game speed, since it is from the settings variable, if we change this, its value might be permanent since we increase it with the factor. So what we'll do, whenever the game start, we'll reset it with the initial value, which is not changing. So our game speed is reset. Now let's create one variable to track score. Let score and initialize it with 0. Now let's create like empty array for dinos. So here I have created array instead of single object, though we'll have a single object only, because when we are creating the AI trainers, there will have multiple dinos at once, and the same will be drawn also. So for simplicity, here also we'll create one like array only, and inside that here we'll add just one dino. So let's create one dino object. Let's import the dino. Okay, now let's push it to the array. So dinos dot push and push the dino. Okay. Now let's create the object for base. So new base. Let's we'll have to import this as well, and let's create object for cloud. So let's say const cloud is equals to new cloud. Okay. Okay, now let's create array for cactus and bird. Since we can have multiple cactus and birds, let's initialize it with empty array for now, and we'll eventually add the logic to push the cactus is there. Now let's create one loop that will keep running till our running flag is true, and when it becomes false, the game will be like over. So let's create one flag that will track that, initialize it with true, and then let's add the repeating logic inside this while loop. First thing, let's check what is the mode of human player. So if human player is in jumping mode, so we'll like make our dino jump. So let's say dino dot jump. Else if it is in let's say not in jumping mode but in ducking mode, so human player dot ducking. So if it is in ducking mode, we'll make our dino to duck. Okay, otherwise we'll like every time if it is not in let's say jumping or ducking mode, then it should be in the normal mode, that will be like unduck mode. So let's call else dino dot unduck. So dino dot unduck, and after doing all these things like jumping or ducking, we'll actually move our Dino, so the actual y displacement and all will take effect, and it will change the position. So let's say Dino.move, and same way let's move all other objects as well. So let's say base.move, cloth.move, and whatever objects will be present in the cactus, so let's move all those things as well. So let's say cactus.map, and then we'll move all the cactus using this map. So cactus.move, same way let's move all the birds. So birds.map, whatever bird is present, let's move that. So bird.move. Okay, so now all our objects have moved. We'll now check for like collisions and all. So what we'll do is we'll loop through all the like cactuses that is there. So let's say cactus.length I++, and let's check if cactus at I dot collide, means if the cactus has collided with the Dino. If that is the case, means our game will be over, so running will be false. And let's break out of the loop, so no need to check for the other cactuses if any cactus collide. Let's add the similar logic for bird. So this time it will be birds.length, and then let's check birds at I. If it collide with Dino, again the game will be over, so need to check for other birds. Now let's see if any cactus or bird have crossed the left limit, so those will be removed from the array. So to track that, let's create empty arrays with rem cactus, and let's say let rem bird, and that will also be empty array by default. Let's use this loop and we'll update it. So if cactus.I and it's not collide, but we'll check its position. So if like its position plus the width, means it has totally crossed the left limit. So if it is less than 0, then we'll add it to like rem cactuses. So let's say rem cactuses dot push, and then add the cactuses at I into that. Okay, and every time the cactus is crossed the limit, let's increase the score. So we have successfully made one cactus crossed, and let's do similar thing for birds as well. So every bird cross, that also will be removed, and will increase the score also. Here now let's push the birds at I. Okay, so now we have added the cactus and birds into that array for removal. Now let's add logic to actually remove it. So let's say let I is 0, I less than let's use rem cactuses dot length, and I++. So we loop through all the cactus present in that rem cactus, and let's check its index in actual cactuses so that we can remove it from that index. So let's say cactuses.index of, and let's pass this object like rem cactuses at I. So we'll search this cactus into our original cactuses object, and find its index, and like if it is found, so if like index is greater than -1, so if it is not found, means index will become -1. So if it is greater than -1, so we'll actually splice the cactuses array at index and 1, so it will remove that element. Let's do similar thing for bird. So let's say rem birds dot length, and it will be searched in bird array. So let's say bird, and same let's splice it from the birds array. Now let's add the adding logic. So let's say if not human player dot like adding bird, so if and cactus, so if we are not currently already in the adding process, so in that case we'll actually add the like cactus, so we'll make it true, so the adding has started. So if it has started means it will not be allowed to add again until this process finish. Let's create one method here where we'll actually add the logic to push the new cactus into that array. So let's create one method add cactuses. It will accept cactus array, and let's make it static so we can directly call it using class name. Let's accept cactuses here. Okay, and let's say at max at a time we can have 3 cactus, so it's not like we're not overfilling the screen with cactus. So if length is say less than 3, then what we'll do is we'll put one random timeout, and then once that timeout exceed we'll actually add the cactus, and we'll put dynamic behavior by using the random, so that it will not be like every time it will be added after fixed time. So let's say cactus is dot push. Let's create a new cactus here. I have to import the cactus. Okay. And when we are creating new cactus, we have to pass the image as well here. So like it can be random, so what we'll do is we'll get a random number between 0 and 1, so it will either choose a single cactus image or 3 cactus image based on this. Okay, and once we add the cactus, let's reset the flag. So human player dot adding cactus, let's make it false now. So we have already added the cactus, it will be false, and then add the timeout value. So let's say util dot get random number between let's say 5 to 10 seconds. So let's add that behavior here. And once this is done, let's do similar thing for adding the bird. So it will become add birds, and it will accept birds. So behavior is going to be pretty much similar. Instead of cactus, we'll add bird here. And bird will not get any image, so bird will have like a flapping behavior, so it will get image by default during like initialization from constructor. So it should be fine. For bird, let's increase the time. Let's make it like 10 to 20 seconds, so it will be like less frequently added. Then let's come here, it will be adding cactus true, and then we'll call that method from util. So util dot add cactus, and let's pass our cactuses object, means the array. Let's do similar thing for the birds. Okay, finally let's call the draw method and pass all our objects to actually be rendered on the screen. So let's say draw, first object is context, then we have to pass base, cloud, dinos, and then we have cactuses, birds, and the score. Okay, and then let's add a delay, means whatever fps we want to use, like how many frames per second it should come. So we'll add that much delay. So if we pass like a fps of 30, means 1/30th of the second this loop will run. So means it will run 30 times in a second. That will give like 30 fps effect. And now if you see, the draw method also accept highest score generation and from trainer flag. So since it is not in use for human player, we'll pass it as default value, let's say 0 0 for now, and from trainer will be false, so that it will be ignored and it will only render whatever is needed. So let's complete this method. So we'll call the draw method on all the objects that we have already defined, and by default we are clearing the screen every time this method is called by calling clear tab. Then let's draw base, call base.draw, and let's pass the context. Same way we'll call cloud.draw, and for dinos and all, since it is array, let's call it map and dino.draw. Similarly for cactuses and birds. Okay, now for text and all, we'll define a font, let's say 20 pixel, and Arial font we want to use, and then let's say ctx dot fill text, that is used to draw or render the text. Let's give the text value, so score, let's interpolate the text using dollar curly brace, pass the variable score, and now let's give its x and y coordinates. So we want it to be rendered on the like, let's say right side of the screen. So we'll give a higher x value, let's say 1000, and some offset for y, let's say 30. So it will come on the right side, means top right part. So it should be fine. Let's launch this application. It was already running. Okay, let's start it again. So seems like there is some error. Let's see what is the error. Okay, somehow its settings and utils are not loaded in some file. Seems like the imports are not proper. Maybe we have missed JS while loading, that's why it's not able to find these files. Let's check all our files and add all the imports properly. Okay, now if we click play game, we can see like it is rendering, but the like dino is above the base floating there, and there is some issue. Also the game is stucking somewhere. Let's see what is the issue. Nothing on this screen. Let's refresh and try. Okay, so it's saying cannot read property of undefined draw image at bird 14. So draw image it's not able to find. Let's see if we are passing the ctx. So first thing let's do is add some offset to the y coordinate of Dino so that it fit on the base. So like to the y coordinate max y and all, let's add some offset value. Okay, now if we see the ctx is not been passed from here, that's why it was not rendering those values. So let's pass that ctx. Now let's save it and let's try again. Okay, so now the Dino is properly aligned, it's jumping, but some issue is still there. So it's saying something is not image. The Cactus 12, it is not image, it is saying. So let's see why. So where we are creating the cactus, we'll check like what exactly we are passing for the value. So in util we are creating the cactus. If we see instead of image we have passed a number here, like the random number, only the index, but we have to pass actually the image. So let's add the image there. Okay, now it should be fine. It is ducking, it is jumping. Now the problem is the cactus are floating, so we have to add some offset to that as well. So let's go and add some offset for that. Okay, now everything is properly aligned. Now let's see if it's working fine. Okay, so it seems fine, but the problem now is new birds and new cactuses are not being added. Let's check why. Okay, so seems like the adding cactus becomes true and then it is not becoming false, which causes like neither new cactuses are being added nor this condition is meeting. So when the cactus length is less than 3 from the human player class, the variable is set to like true adding cactus and it remains true. So we'll have to remove this length check somehow, and we'll actually move it to, let's say, the human player itself. So let's remove it from here. For this also, let's remove it. And let's add it to here itself. So like if this cactus we are not currently adding and the total cactus is less than 3, then we'll add same for bird. Okay, now let's try. So now it seems fine, everything is being loaded, cloud is loaded, base is loaded and moving leftward. These cactuses are coming, Dino is running. Okay. Let's remove bird for now, just to make it simple, and let's play without bird. Okay, so now everything seems fine. We are able to play the game. We can duck, we can jump, everything works fine.